Welcome to the Crazy Wisdom Podcast. My guest today is Ian Mason. He does architecture and delivery of AI and ML, including LLMs and RAG. Most of my listeners are probably familiar with all of those terms. We got data analytics and data engineering full stack solutions. So welcome to the show.
Thank you very much. Really good to be here.
Yeah. Longtime mutual, very on Twitter, and we're going to go deep dive into all the different stuff that you talk about. And we were just talking beforehand about how I want to create a knowledge graph. And I've heard the term knowledge graph thrown around so many times. And now with AI, I'm able to go whenever somebody says something, I'm able to go do the studying on it and get it really quick. And so now I think I've got what a knowledge graph is in my head. It's taken me 6 months to figure out what it even is. And at first, ChatGPT sent me down this total rabbit hole. I asked it, how do I make my podcast how do I make my podcast into a knowledge graph? And it started giving me the pre-trained BERT models, all of which now seem to be totally obsolete because now we just have the foundational models, which can do all of this different stuff. Is that an accurate representation of what's happened? Like, would you still use the BERT model? Is a transformer?
Yeah, I'm actually not incredibly well versed in the full detailed history of the development of LMs. So when BERT came along versus BARD, for example, which is of course later with Google. Yeah, I'm not entirely sure. So I think that you were diving towards knowledge graphs, though, right? In terms of where you're headed. It's been on my list. I mean, we talked about this a couple of months ago when we were starting to chat about this podcast. And certainly I aim to get into knowledge graphs because I've had with one of my clients where I did implement a language model, and it's to support a service team and how they kind of draft emails automatically and so on. And because the service team is dealing with kind of sophisticated architectures, it's all to do with IP-based equipment on customer sites. What we found immediately was that, of course, LMs work statistically. They work in terms of just predicting how would I answer this question, right?
Yeah.
They don't think about architecture. They don't think about what A links to B links to C and so on in terms of truth, in terms of actual equipment out there in the real world. If you describe that in an article, and that article was ingested,
got it. Yeah, interesting.
Then for sure, it's going to be able to draft an email on that basis, right? But it can't think architecturally. And so my hypothesis is that it may be that if you're able to not so much merge, but create a hybrid system where the language model is responsible for articulating answers, but some other system which is more deterministic and logical and using a knowledge graph which could emulate, here's the actual architecture for this solution. Here are the routers that connect to the IP switches that connect to the final speaker device or whatever the case is. Wow. And you could deduce the answer that way and then feed it into the LM for articulation at a language level. I think you would have a pretty great solution there. But people do try to merge. Sorry, go on.
Yeah, it's super interesting because we could go deeply into philosophical territory from here. And that's what I love about LLMs is it's all language based, so it's all like like linguistic nerds love it, and it's all very different from previous automations, which is like also philosophical. Like I'm not saying that automations themselves aren't philosophical, representations and all those different things and like processes. Yeah. Logic and all those things are very philosophical as well. But now we're in much deeper, which is like symbolic things. And you just gave me a really interesting insight, which is that LLMs can make it sound like they understand a lot, but it's a very superficial knowledge unless they have it not only in their training data, but also the prompt itself needs to somehow get that training data and make it relevant with the prompt. And then there's this other thing about bringing from the latent space from going the RAG, I believe that's what RAG does, is it goes and goes out into the data that's not part of its training data or maybe part of its training data and then bring it in. And what you're saying is that it's almost like you RAG the knowledge graph, or no, you build the system behind the LLM with this knowledge graph. Is that right? Where did I go wrong if not?
No, that's actually a pretty good description. I would say that first of all, RAG is actually incredibly useful because it does supplement or replace what's in the training set
Yes.
for an
Got it.
LM.
Oh,
So
good
you're
point.
able to focus the LM on you're going to find the answer to this question in this context that I'm going to feed you in the prompt because I did a pre-search in the RAG database.
Oh,
Um, so, we've got a set of FAQs or a set of product sheets or product knowledge in the RAG database, or the vector store is really what it is. We're going to pre-search that. We're going to get the answers out of that, or the most likely answers, and we're then going to feed that almost like spoon feeding the LM. Like, don't worry about your training data. Don't worry about what you learned on Reddit or from, the entire internet. Just use this stuff. This is actually holding the answers somehow. And then the LM can go ahead and just say, oh, okay, since you've given me all the possible answers, I can now articulate. I'm not going to hallucinate very much. I'm going to focus on what's probably, I'm going to focus only on what you gave me. And now I'm going to articulate the answer on the basis of that. So you're actually circumventing the training data in a way. You're still relying on it for its like deep knowledge of grammar and the logic of how to give long answers and so on. But the actual granular facts that it's going to use are from the RAG database, not from its training set. Usually, I mean that it's not perfect. It'll sometimes go to its own set and be like, "Hey, let me supplement it with this extra thing," and you'll be like, "No, we didn't need that extra thing. Don't be doing that." But having said that, so RAG itself is quite similar to LMs because that vector search that you're doing
yeah.
to come up with the most likely answers is actually, you're using embeddings, which are the core technology of the LM itself. So the way that you're finding the right answer is actually the same way that the LM itself would have gone into its own training set to find its own right answer, but you're doing it first using that same technology. You find the right answers, you pull them out, you hand them to the LM, just express it using these. Now, having said all that, now we have a knowledge graph into this mix. And a knowledge graph is just like an old world way of just creating an ontology. The word is
Whoa.
ontology, right? It's like this kind of notion of how do I describe all the entities in an environment, all the entities, let's say, in the financial sector. So
Yeah.
there are private banks and there are investment banks and hedge funds, and here are the attributes of each of them. And here's how they all relate to each other, right? Just like in a graph, you have nodes and edges and that sort of thing. And that's constructed normally in a very human way. You literally sit down and build up a graph database that encodes all of these entities
Oh,
and relationships. And then so there's two ways of doing this, right? Like you may build it out deterministically as a human. You're just going to
yeah.
say, here's all the knowledge I have
Yeah,
of
yeah,
this
yeah.
sector.
Or you
I'm going to put
discovered.
it in.
Yeah.
Yeah, and so now you might run code against that to say whatever answer we're going to give to the LM to then articulate, we're determining some of that answer through just deterministic code looking at a knowledge graph and saying, these are the 5 things that relate to each other. Here's the core idea. Here are 5 children ideas of the core idea. Everything else is irrelevant, so just focus on those. We might then hand that to a RAG system that then says, okay, given that we've got the 5 ideas really nailed down, let's go into the RAG database and do a more focused search to find the right answers.
Brilliant.
Because now we're not doing similarity searching as much. That's the tech underneath a vector database, is this kind of semantic similarity or vector similarity, cosine similarity. These are all the same concepts. Now you're actually pre-narrowing that search so that the answers are even more relevant. Now you send those answers into the LM. That's hypothetically one way of doing it, right? You're going from deterministic answer finding within the knowledge graph into non-deterministic but still focused answer extraction from the vector store, and then into the non-deterministic LM for final articulation. Other people might say, no. What you can do, in fact, is create a knowledge graph using a language model. You can tell it, here's a fact base. Please derive a knowledge graph out of this.
Oh, that's what I need to do. That's what I need to do for my
I
final.
don't know if it works very well.
Oh, okay, got it.
So,
Yeah. Got it, got it. Yeah, because that's
I've
that's
seen,
probably more
yeah,
technically challenging because the deterministic way is the way that people have traditionally done it. Is that right?
Yeah, I mean, essentially what you're doing is you're taking, like, to my mind, the risk of it is that you're taking a perfectly deterministic set of facts, which is what you would get if you created the knowledge base as a
Yeah,
human, as an expert,
yeah.
and you're now throwing it into that probabilistic world of the LM, going, "Gee, I hope you can figure this out." And I've seen experiments where people have done this, like really smart people on LinkedIn have said, like, "Watch how I create this knowledge graph out of, using an LM." And of course, it's always about movies, right? It's always like this classic movie base that everybody uses for creating
Ah,
knowledge graphs, like what actor was in what movie, directed by who. It's like the standard Neo4j like example set that everyone uses. Um, and you can see that a knowledge graph comes out of it. But my immediate thought is like, are you sure that it's the right one? Because again, you're giving it to an LM that's going after things kind of probabilistically and not in a very language way of doing things, right? And a knowledge graph is not language, right?
oh,
Language has
interesting.
its own statistics, and a knowledge graph can be completely different from that. I mean, think about a telecom network, right? That's a knowledge graph. If you could say these are routers, switches, they're connected in the following way. They connect to people's phones, right? In the following way. This is a hierarchy of routers and switches and phones.
Uh,
That has nothing to do with language, right? Now
right.
you're asking the language model to try and
Oh,
somehow deduce that from what? Documentation? Yeah, it might get some of it right, but it's not really going to get it right because it doesn't really understand the architecture. It understands language. That's different.
that's brilliant. Okay. Yeah, and it's so interesting because this also brings in the multimodal part of
Right.
everything. Is the what OpenAI is doing, what Claude is probably doing, a lot of other people are doing is multimodal. See if I can bring this back. Somebody explained it to me, and it was a brilliant explanation. Um, so multimodal, it's like the tokens themselves that it doesn't have to be broken down into a whole other network. You can just have the token be processed in a multimodal way. Is that accurate? Did I get that right?
I haven't dove into
To multimodals.
multimodal
Okay.
deeply, and I'm still wondering if it's like part of it is like the mixture of experts approach, where you actually have within a language model several language models, or some of them are like, graphic diffusion models, and some of them are
Yeah.
language models, and
Yeah.
it's kind of
Oh,
housed in a
that's what a
package that you call a single thing. Well, I may be misdescribing it because there might be with multimodal a much more subtle with that thing which you kind of
got it.
described with
Yeah,
kind
yeah,
of
yeah.
a token and not predetermining whether it's a language token or a pixel in a sense. So I don't want
Well,
to
yeah,
kind of
go
speculate too
outside your wheel book, and I appreciate it.
much.
So but what so the multimodal, I think what we can say there, because both of us are unclear on this, is that the
Yeah.
multimodal is like inference. There, well, inference. I learned recently what inference is, and inference is anytime that the model goes out to like processes, it has its training data, new token, new thing has happened, new
Yeah,
data has been entered, it goes and does that process.
right.
Now, and that's somehow related to the multimodal. And now what I like about what you described is the knowledge graph almost seems like it's like a philosophical, like metaphysical, like almost like what is the
Yeah,
structure of reality type of thing. So
right.
like a there's a brain analogy, but it maybe like maybe it's like a distributed brain is better of it, like the combination of all of our brains. That's what creates knowledge type of thing. What do you think about the term artificial intelligence? Do you think that we have artificial intelligence, or is it something else? Did they use the wrong descriptor?
Um, I think it really the ability to call anything artificially intelligent comes from that original idea of, the Turing test, right? Where it was all black boxed. And the concept was if you could just, fool people into thinking it was intelligent, then maybe de facto it is in a sense. Maybe we've created something that is sort of at some fundamental level intelligent because it behaves intelligently. So that's like I think there's the Searle as well. I think he's got Searle's Chinese room, if I'm not mangling
Uh-huh.
that. But this whole notion of because we look into each other's mind, we only have our own minds. We ourselves are aware that we are intelligent.
Yeah, got it.
But you might be a bot, or I might be hallucinating you, or something, right? I'd be sure that you're intelligent, but I know that you behave in an intelligent manner. So the imputation is you're probably intelligent then, right? Because you're a human like me. That honestly, I think it's been stretched too far nowadays, right? That notion, because
Mm.
we do know, obviously, how traditional AI works in terms of, regression, logistic and linear regression and things like that. This is all like classical AI machine learning. Deep learning is an extension of that into obviously multi-layered neural networks, but it's still linear algebra that's being performed. A language model is also linear algebra being performed, but on a different set of inputs, right? Instead of staring at cats on the internet, we're now staring at long strings of text and imputing from that all sorts of features and attributes. Uh, but it's still just linear algebra. So everything that comes out the back end of that, which is the response from an LM, can again seem very intelligent, but we know for a fact that full like intelligence does not occur. Linear algebra is occurring within the box, and that's that.
Oh.
Um, Now, the response to that might be, well, how do you know what's going on within your own neurons? Maybe it's just linear algebra, right? Or, some sort of biological version of linear algebra. Um, and that's, I guess, a fair response. But I think we also know that while humans can look inside their own minds and intuit that they are alive and aware and conscious and thinking intelligently, a linear algebra box is not doing the same thing. Even though its properties are really interesting and emergent and doing things we weren't expecting, again, it's just math happening within there.
Brilliant. Now writing on Twitter. This isn't artificial intelligence. It's artificial linear algebra. I like it. Okay. What's your Twitter again?
Good. We'll kick off a firestorm.
Yeah.
What's that?
What's your Twitter handle?
Ian Garrick Mason, all
Ian
one word.
Eric. Found it. Okay. And okay, yeah, brilliant. So it's artificial linear algebra. I really like. I'm gonna start stealing that. I've been calling it artificial knowledge because I don't think we should call it artificial intelligence. I think we should. It's closer to artificial knowledge, and this goes back to the knowledge graph. But it's actually, I think it's better to call it artificial linear algebra because that really demystifies it. Because there's a lot of mystification going on around here, and that we could strongly diverge into a critique of San Francisco and just the total nonsense that's going on there. Well, yeah. What do you think? What do you think's going on in San Francisco? Have you spent much time there? Are you?
No, it's been like 30 years since I visited San Fran.
Yeah, interesting. How does it appear what's been going on for the past 30 years? Like how has the brand inside of your head changed over time?
In terms of Silicon Valley as kind of an entity,
Yeah,
you mean?
Silicon Valley that shifted into San Francisco and the mindset, the like from
Yeah.
an outsider perspective, like what is going on there?
I think that I mean, obviously, there's a bunch of variables being injected into this like dynamic system we might
Yeah,
call Silicon Valley, right?
interesting.
And there's a variable which is just, the purely natural technical progress and insights that we didn't have, or that mixture of hardware and software as it comes together, where, people like Jeff Hinton in the 1990s come up with like very early neural networks, but they don't work very well because they're built out of, boxes and wires, basically, right? Because it's the 1990s, you can only have like a layer and a half, whatever he had, and only so many neurons, but the idea is like, oh, look, this is possible. And then along comes graphical processing units 15 or 20 years later, and suddenly everyone's like, oh, these things do linear algebra incredibly well because that's what they were built for. Now we can do neural networks. Now we can recognize cats. That's really exciting. So there's that natural technological progression, which of course at each stage opens up an opportunity space. But I would describe opportunity spaces as, because that almost sounds like everything in that space is an opportunity.
Mhm.
And in fact, 99% of what's in that space is not an opportunity, it's a dead end. It's actually like, this won't create any business value. It just looks kind of cool, or we
Yeah.
don't know yet. We'll have to experiment. And of course, the role of venture capital companies and ventures themselves is to go out there and experiment. I mean, my ongoing analogy is in the mining sector, because I used to consult to the mining sector many years ago. And they have this ecosystem where you have, of course, massive mining companies that do the proper extraction of the minerals and processing and shipping and so on. They're creating the kind of 30-year value after you found a mine. But you have all these like 1 and 2 and 5-person companies, like hundreds and thousands of them, that just go out and are looking for minerals, right? Prospectors, right? Like guys that used to put on hats and sit in the water and look for gold. And the whole point of those companies is to actually burn out like fireflies, like make little bets. Investors just put their money into them. 95% of them burn out, or they find something, but it turns out to be non-economic and nobody can extract it and make money off of that. And the people doing that know that they're probably going to burn out, but they'll make their living wage while they're looking, and then they're going to look for something else and make a new company and get new investors, place another bet.
Yeah.
So technology is the same way. We're moving into a space, just like miners move into a space. They look at a 200 square kilometer tract of land, and they're like, I have a hypothesis that there's gold in those hills.
Yeah.
Likewise, tech companies say, I have a hypothesis that in this space of LMs, there's gold in here somewhere. And off everybody goes looking for the gold. While that's happening, you have the same, of course, this is nothing new. This is the gold rush metaphor, right? You have everybody rushes into the space. Everybody turns to their venture capitalist company or their VC firm, who are, the investors turn to their VC firm. They're like, why don't you have a bet in this space? Like, why don't we have 3 of our companies in the portfolio as AI companies? That's where it is. And the VCs are like, you're right. We're looking. And the VCs that are late to the game or don't have the best offer are getting, these kind of tail end kind of AI plays, which are like, these are not going to work, but we got to tell somebody that we're invested in the space. Likewise, pension funds are doing the same thing, and everyone has to say they've got an AI play. And then you have the burn rate, which is this zone of time where somebody dropped 20 million bucks into your company. You've got like probably 2 years of time to do your best shot, but you're also burning the money as fast as you want to and buying your new furniture and blah blah blah, hosting your conferences. And if it doesn't work out, obviously you're just hoping you're going to leverage that and jump to something else.
Yeah.
So there's definitely you can see where the hype comes from, because you need to get the funding. The funders themselves have to justify it. Yeah. Everyone's taking the smallest piece of evidence and spinning it upwards into, this is why this is going to, make us all millions. And at the same time, we also, and this is, let's call it the plus side of things, as a whole ecosystem, we still have to work out, what do we really think about this? Like, what is really going on, right? And even thinking back a year and a half to when the hype boom started around ChatGPT and so on, it took a while for like most people to just figure out like, how the heck does an LM work and what is it really doing? Yeah, and what are its limits, right? Because I remember small business people coming to me, like clients, and they'd come to me and be like, and this was before I got into it as well.
Yeah.
And they'd say, Ian, you've got to do this. You've got to not just consult in the space, but you got to use it every single day. I've got ChatGPT drafting marketing presentations for me. It's the best thing ever.
Yeah.
And I'm like, what's it drafting it on the basis of? Like, how does it know anything about your business? What did you give it? And of course, they're just giving it, please give me a marketing presentation. I do this kind of work. This is my company. And it gives you this plausible presentation. Great. And that's really impressive until you realize that it's just based on all the other presentations it read in the training set. So of course you're going to get this like mildly well phrased, decent enough start, but it's nothing to do with your business unless you're doing things like RAG. Okay.
Yeah.
Okay. Right.
That's a great entry into it. But there's one question I want to highlight, which I already posted on Twitter, is how much do new funded startups spend on conferences? Because that feels like an interesting insight that I hadn't thought of, is like that they probably get a lot of money. But actually, I should let you finish your point, because you were saying that it's a good side. There was a good side. There's a good side to this, because that's the negative hype of San Francisco. And then there's a good side to it as well. And you're talking about the small businesses and how they're using it. What was that wrap up of that thought, basically?
Yeah, it's really we have to go through this process of publicly conversing about what is it that we have here and what are the limitations of it, right?
Okay. Yeah.
Naturally, hype goes away on its own. It does it for every single cycle that we go through. It's usually a painful process. Obviously, many businesses go bankrupt as part of that, the bets didn't work out. But it sort of has to be that way. I don't think we can ever get rid of hype. It's been as old. Every snake oil salesman from the 19th century did hype. It's the way humans are. Of course,
Yeah.
we're going to hype what we got.
Yeah.
Um, but that process of talking about it and experimenting with it and slowly coming to grips with, hey, you know what? LMs are not as transformative as we thought.
Mm.
There's still some very interesting potential in how they may develop. And there are definitely some business cases where they are useful. They do produce actual economic value. They do improve people's profit margins. So they will be useful. They're probably going to stick around forever in a way. The questions then are, in what way? Are they going to be gigantic and keep getting bigger? Are they going to get smaller and more specialized? Are things like the ability to fine tune them or to use RAG in very sophisticated ways, or knowledge graphs, those sort of things, like full solution sets of how will an enterprise 5 years from now be using LMs? They may be embedded in bigger things. Salesforce is very good about embedding AI into their various tools. Although their LMs are currently external LMs and they just pull them in via API.
Mm.
But many big companies are looking at, can we just nest LMs within larger systems so that
Yeah.
people don't have to worry about, oh, I'm talking to an LM now. I have to do this special thing and use these magic phrases. And how do I do prompt engineering? Just to simplify it so that it's always in the background, doing different specialized tasks or creating a generalized interface for employees, for example, so that if you have any general question about, if you just got hired, right, you go through a 3-month ramp up of, I have so many questions at this new company
Yeah.
I work.
Yeah.
Well, maybe there's a little portal where you just constantly go and ask questions, and the LLM very intelligently gives you pretty good answers based on the knowledge base that has been fed to it. So there's all sorts of different, both specialized and more general roles for LMs. But I think that my impression, after I guess, a year now of working in the space, is that I think that the way they create value will be, it won't be a letdown because it is an important step forward. But I think, compared to that
Right to
hype,
the hype. Yeah, yeah, the AGI
yeah,
hype. And this is all predicated because
right,
it's so interesting that what is the what's going on, because my understanding of what happened in the last 2 years is that there's so much hype from 2015 2016 when Elon Musk started to become more vocal about what was going on with AI, and then everybody in Silicon Valley kept on hearing words about AI, and boy, I wish I had gone and understood what a GPT was. I probably never even heard that term until they came out with it with the
yeah,
3.5, until OpenAI came out with the 3.5. And that moment was like, okay, oh, there's something here. This is the first time I understand what AI is, what that hype that Elon Musk was talking about. And then 3.5 was kind of revolutionary. And then I got into a middle of a company that was helping OpenAI do their thing with a specific algorithm. And then 4 came along, and it was just like a crazy thing. But my understanding of what they did by doing that, they were trying to get more training data. They had not run out of training data, but they
yeah,
needed more training data. And so they
yeah,
released this chatbot product that was the main purpose of was to consume more data, to get more data so they could train their next model. And now there's two really interesting things that happened in the last year. Both of the major announcements that OpenAI has made have both happened exactly at the same time as Google has made their announcements. And
yeah,
the Sora one was the most interesting one because they released Sora literally like the day that Gemini came out or something like that. Like Google's like, oh, we got this new model, and then boom,
yeah,
OpenAI's like, oh, well, we got videos, we got like full scale videos and stuff like that, and
yeah,
then completely capture the marketing. And then the second one was Google was having their conference, and then GPT 4.0 showed up. And I know there's something multimodal going on in the background that we were talking about earlier with the GPT
yeah,
4.0, but it's not revolutionary. It hasn't changed my life in the same way that the ChatGPT 4 definitely changed my life. And you got all these other, you got Anthropic, you got Google, who has this powerhouse. But so far there hasn't been a qualitative change. Like there hasn't been like, but they're whispering about it. They're talking about AGI. Sam Altman's making jokes about AGI. Then you got
yeah,
Murataki saying like oh no, well, PhD, blah blah blah. So it's like there's a lot of talk, and it's still unclear to me whether they're going to have. I mean, this might bite me in the ass saying this a year from now. They might release GPT 4.5, and it just totally blows it out of the water. But there is also the possibility that they are really good marketers, that they just know how to capture the audience in order to get to the top player level, and that LLMs aren't like you're saying. It's sort of like LLMs are really cool. They're really amazing. They're going to do some amazing stuff, but it doesn't seem like they're going to take over the world. It doesn't seem like they're going to destroy us. Like, I have seen no evidence of that. Deep fakes are now starting to come out, like real deep fakes with, I'm sure you saw the Dave Chappelle one. But yeah, it's a really interesting time. Maybe I should start making predictions in the prediction market to like really make it more like, okay, this is what I actually think and willing to bet money on, and like whether I'm right or not. What's your take on all that?
Yeah, I think that AGI, first of all, incredibly hard to define well. I think there's another deep philosophical conversation that many people are having. I think I saw snippets of Jan LeCun talking to Lex Fridman about this. So there's one point, just being the embodied nature of intelligence, right?
Yeah.
That
Ooh.
even if you could and I've long thought this as well, that even if you could hypothetically come up with a box that is as smart as a human or 10 times smarter than a human, sort of doesn't matter, um, how it could understand the world beyond simply having some kind of imputed models of it, versus how we understand the world, because we are living animals and we walk
Yeah.
around in the world, we feel gravity, we see things with our, telescopic eyes and so on, with that kind of vision, or duoscopic, I don't know what the term would
Mm.
be. We feel pain, we age. There are all these
Mm.
ways that intelligence is formed holistically when you think about it, that pure logic boxes cannot come close to. And I think the more people ponder that, the more they start to come up with solutions like, oh, okay, well, we'll put the logic box inside a robot and it can walk around.
Mm.
And at some
Yeah.
point, I mean, I started laughing because I think like, well, all you're trying to do is just like create a human, and we can do that incredibly cheaply, way more fun.
Yeah.
The natural way. Why are we
Yeah.
just trying to recreate this? Um, so can they cause harm? I think they can inadvertently. Like I don't think
Yeah.
certainly in the next 20 years we're going to see some sort of chatbot deliberately attempt to do something, like come up with on its own like some like really cunning plan and go off and be Skynet. I don't think we'll see that. I think what we will see is dumb mistakes using things like agents, right? So agents is this concept of let's
Yeah.
attach a chatbot to an actual thing that does things in the real world, whether that's a robot or simply like a thing that schedules stuff in Outlook, right? And people are experimenting with that. I constantly trip over videos of saying, this has transformed my life because I now have it book all my meetings or whatever.
Yeah.
Uh, okay,
Have you used
fine.
an agent?
What's that?
Have you developed an agent? Have you used an agent?
No,
Yeah.
but I mean, with knowledge graphs, that may come up, right? Like, because even when you get
Oh.
when you call, like, say, Python code before you go to the LM, and you say, like, hey, just compute this for me. I need a definitely true mathematical answer. Now I'll feed that into the LM. That's kind of agent-like, right? Or you get the LM to know that when I actually ask it something in a prompt, like, please compute this difficult problem, use Python, it'll like stop being an LM for a second and just kind of call another piece of code, run it through that Python function. It'll spit back into the LM, here's your answer. LM then says, oh, it's 3. And it's true because the LM itself didn't try to figure it out. It kicked it out to another piece of code. I'm pretty sure that's kind of the definition of agent work, right? This kind of like attaching deterministic functions to this non-deterministic language model. Um, and I think at a personal level, people can experiment with that as much as they want. And yeah, sure, if it's 95% good at doing what it does, maybe it does make your life a bit more productive. But when it comes to enterprises, any company more than one person, would you actually put that 95% accurate, i.e., 5% inaccurate, i.e., every 20 times it does something, it gets it wrong? that's going to be insanely irritating, if not destroy your business, right? Like just like 1 out of 20 times, because like every process in business is actually happening 50 times an hour or whatever the tempo is. You're going to get a lot of wrongs, right, through a business day.
Yeah.
So these things need to be 99.999% accurate, and they're never going to get there, not a language model.
Yeah. And that reminds me of the really important of having a human in the loop for particularly the agents. I wonder what it's going to look like to do quality analysis on agents' work. Have you thought about this at all? Like having in the QA position, checking over agent work?
Yeah. So they're definitely I think the agent work might be easier in a sense because
Mm,
if you're doing something deterministic, it's
yeah,
either right or wrong. The
yeah,
math is either correct or not, and you can actually run other programs against that, just the same way you do unit testing of your code by saying, this part of the program is going to say, I predict this function should give the answer of 10 when the input is 4. And it checks and says, oh, it is 10. I guess the function's working well. But what's harder is actually language model articulations and looking for hallucinations or looking for just incorrect language or toxicity as they call it and things like that. Um, because that comes down to, I mean, there are definitely attempts all over the market. People are coming up with evaluation software for LMs.
yeah,
But the fundamental problem is, even if you asked a human to evaluate it, the
yeah,
human would sit back and be like, well, I don't know. That's pretty good.
yeah,
But I'm not even sure what I was shooting for. Like, what was the standard of how a client email should be written? And every case. I don't know. That's impossible to kind of define, right? You can definitely look for like, oh, the LM started spouting nonsense in the middle. That's clearly wrong. Okay, that's an easy one. But yeah, to do it on like
it
how
takes
close does it
taste.
come? Yeah,
It's taste. It's subjective taste, and
yeah,
this is not a new problem. That's a very old problem, and it's a problem that will continue on in the future. And
yeah.
this is what I love
Industry.
about life and like the area that I come from that talks about, oh, just throw some technology on that. That'll work. That'll work. Yeah, that'll solve all our problems. And now they've got a
Yeah,
whole philosophy. I'm being too hard on them, but I've got some anger. So like it's turning into a religion about it already is a religion. Just throw some technology on it. Oh, pretty soon the technology will be the god. Okay, all our problems are solved. Okay, nobody works anymore, but don't worry about it. We'll have the abundance and everything like that. It's like no, the like we're just at the very beginnings of understanding. Like it feels like we're so not enlightened. We're not modern. We're like one stage out of the jungle, basically, like one little
yeah.
tiny step out of the jungle, but we're still in a jungle. And it's like, and it's just like it's really fun and funny and ridiculous. Okay, well let's kind of bring it back into the RAG and the knowledge graphs and the this is really good. The vector database, that's something I still don't understand. Basically, there's why doesn't an old school database work? Why do we need a vector database?
Strictly speaking, to do RAG,
Uh,
you probably could do some sort of thing with an old school database in the sense that all RAG is really trying to do is to pre-select the better answers from a limited knowledge set,
okay.
so that your LM doesn't go off the deep end and hallucinate from its massive
Like this
training set.
podcast. It's like what you're doing for me for this podcast. You're just kidding. Yeah.
I am your RAG system.
Yeah.
Yeah. Um, but as we know, because LMs have been trained on the entire internet, including the madness on Reddit and
Yeah.
probably Twitter as well, and so on, that possibility of going off the deep end is definitely way more
Quite
than
high.
none.
Yeah.
So RAG just in principle, RAG is simply saying, let us find the right stuff first and hand that carefully to the LM so it knows what to focus on. So having said that, um, could you do it? Could you do that finding of the right answers in any way that made sense? Absolutely, because at the end of the day, it just goes into the same prompt as extra context. You have your prompt request or command at the top saying, I would like you to create a customer email that summarizes the answer from the following context. And the context is just a bunch of plain text which came from the RAG system.
Yep.
So that plain text could have come from anywhere. You could have a RAG system that's actually just a human being that just sits there and types in, at the limit of silliness, but
Yeah.
that would still be a RAG system. It's just a human typing in, like, it has to come from this knowledge.
Got it.
Could you have knowledge in a SQL database that is just in,
Yeah,
and you
got
do
it.
some sort of a keyword search?
Yeah.
Yep, that would work too. Would it be really good? Not really, because keyword
Mm.
searches are limited. It's incredibly old school searching. So because we had invented LMs first, and LMs use this really cool concept called embedding, which is where you take, strings of text and you figure out mathematically the subtle meanings in that text and how it relates to all the other possible text in the training set. And so you now have effectively a vector of attributes, a vector of numbers, positive and negative, that can be thousands of numbers long. And that encodes the meaning of a given sentence or a given word. Because you're doing that anyway, then everyone thought, oh, well, the most sensible and probably the most efficient thing is have that knowledge base be based on the same technology. So
Yeah.
that vector database is all
Got it.
just embedded vectors of text.
Yep.
And so when you, let's say, have a customer question and you want the most relevant answer to that, you take the customer question, you then embed that in the same way that if you're asking LM directly, you would embed that question and add through the prompt, it then becomes embedded. And then it does cosine similarity to say, of my entire vector, all the records in my vector database, all those vectors in there, which, 3 or n equals 6, which 6 are the most similar to this vector that I'm comparing, this question vector. And you get the 6 best answers in theory. So now there's a trick in there. There's a difficulty, which is if I put in the question, what's a good recipe for apple pie?
Yeah.
You might actually think, oh, it's going to give me like recipes because I asked them for it. But
Yeah.
actually, if you build it wrong, you're going to get responses being like, what's a good recipe for blueberry pie? What's a good recipe for cherry pie? Because those are actually more similar than anything else to that question I asked. They're actually almost
Oh,
exactly the same.
interesting. Yeah.
Yeah, so you have to do a little bit of a trick there where the similarity is on like a question and answer concept as opposed to just being purely similar to the question,
Yeah.
because you'll just get a bunch of other questions actually coming back.
Got it.
So yeah, similarity is not the same as relevance is this kind of key phrase people use.
Similarity is not the same as relevance. Okay.
Yeah,
Oh,
or
interesting.
semantic similarity is not the same as semantic relevance.
Same as relevance. And that goes back into the philosophical discussion, but this is a really interesting one because I had a follow-up question. I mean, the keyword search is really interesting. What you mentioned about keyword search that and what I get from that is that used to be the old school way is that you just have like a database and you would search with a keyword.
Yep.
And then we had many, and I'm going to go do this research with my dad on our podcast where we're doing together, where we go back into the old school, what that meant. So that's a really good for that. But then we were talking about embeddings and we got strings of text and you figured out mathematically and the vector of attributes. So there's like an efficiency game, a performance game gain from using these vector databases. And how hard was it for you? What was the learning curve like to go from a traditional database into a vector database? Like, was it a strong, hard thing to do?
That's a good question. Because I don't actually build the vector databases myself and I don't build
Mm.
LMs, although
Yeah,
I'm trying to learn how they get built
got
and,
it. Interesting.
my
Yeah,
own
you're plugging them
books
together
and so on.
basically.
Yeah, you're kind of building them or you're using them as components in a larger system, right?
Okay.
So the client solution I built that supports the support team, I've built it in AWS and the cloud. I have Lambda functions. So these are serverless functions running Python code. And the Python code is not that hard because all the Python code is really doing is kind of taking in an event, which is the customer email,
Yeah.
grabbing the customer email out of it, then so that's just a parsing function of just pulling the email out of a JSON object, and then it'll take that customer question and throw it against first an initial LM. And my Python code just says, hey, can you take this complicated customer question and break it down into sub questions and just give it to me as a list? And so it then says, okay, yeah, there are 3 sub questions in here. Here's the list of those. And then I have Python code that says, thank you very much. I'm going to parse through that list. I now have 3 very clear sub questions. Then those sub questions get embedded, and I don't need to know the code for embedding. I'm just calling a function within, I think it's a either llama index or I think it's LangChain in this case. So LangChain has libraries, and you just call the library and say, here's a string of text. Please embed that into this particular vector store. And in it goes, and you say, here are the parameters for that. I want the best 3 answers, no score under 50%, things like that. You have various parameters you can play with. Back come the answers as text again, like within an array, and then you just pull those out, and you literally just send them back to the main system and just say, here's the context. Go ahead and now ask GPT for the answer, right? Please draft the customer email on the basis of that. So the beauty of this is that, of course, everybody builds these gorgeous libraries that do all these sub
Yeah.
functions. As a solution developer, you just need to think really carefully about what are all the steps I'm doing, what's the best infrastructure to put it on, and then you just work your way through that logic. And now I'm building out, like, the full stack part of this is now I'm building out an API gateway and a front end so that the client can come in and just say, what do I have in my vector store? Give me a list of all the articles that are in there or all the extracts that are in there. Let me change the ingest list. So when they want to refresh it from their website, bring in all the fresh knowledge from their website, they can say, use these URLs and these paths. And they can just put that into the interface. And so now they have kind of control over their vector store without having to come back to me to say, get into the Python code and
Do
change
this.
stuff.
Yeah.
Yeah, this is just a client interface, right? But that full stack nature of having to, figure out the authentication and the API gateway and develop, little micro Python functions and so on to respond to all the calls. That's kind of new for me. I don't normally do full stack work. So it's been interesting kind of learning how slick that can be when it really works well.
Oh man, that's so interesting. And you used one word I haven't used before, which is solutions developer.
Yeah.
And that feels like that kind of developer is going to become really important, because it's not only the LLMs which are changing the game in terms of, like going back to the previous thing I mentioned about Silicon Valley kind of buying their own BS. One
Yeah.
thing it does seem really clear is that in coding, it's going to be really, really, like, it's going to be really powerful in coding. LLMs seem like they're at some
Yeah.
point are going to, like, really make a change to the, and it feels like it's going to happen soon. And I'm really interested in, I guess, becoming a solutions developer, even though I've just hit my head against the wall so many times of not being very good at coding. But I think I've actually now reached a step where I can actually start to create things in this world.
Good.
Yeah, it's a wild journey, because I started 10 years ago, and actually, there's a great story. I went to a meditation retreat in Mexico. I was like, okay, I'm going to finally learn how to code. It was 2015. I had like 3 or 4 years of people telling me, you need to learn how to code. I was just a business
Yeah.
guy, and it was like, you got to code, you got to learn how to code. And so I'm like, okay, I'm going to do it. And I really need to concentrate. What's the best way to concentrate? Well, meditation retreats are really great for concentration. And so I ended up at this meditation retreat with my computer. And for, like, I think I ended up staying there for 3 or 4 months. I would do 10-day meditation retreats where I didn't use the computer, and then they would have other programs going on, and I would stay there, and I would actually
Yep.
use the meditation hall on my computer. I would bring my computer in there, and that led to a really interesting clash between the sort of the Luddite hippie type of thing mixed with the urban
Sure.
tech hippie who
Yeah.
brought his computer into the meditation hall and was tapping away. I was trying to be silent.
Yeah. I was
But
just imagining that.
and then one guy was like, "Bro, the EMFs. You know what are EMFs, right? That you're clogging my brain." And then he told me this beautiful story about how he was in Switzerland and he had to get away from the city, and he started sleeping in the forest so that he could get away from the EMFs. And I was like, "Oh man, that's a totally different version of reality than the reality I'm living in. Like, what's going on?" And so, but then I gave up. I gave up after, like, I
Yeah.
spent a long time trying to figure out what was going on, and it totally blew my mind. And now that's when GPT 3.5 and 4 came out. I was like, okay, this is it. This is the thing. This was the missing piece, and the missing piece was somebody there right next to me being able to tell me like what's going on. And that's what ChatGPT is really good at simulating. But now I've
Yeah.
found that it's middling code. It's not it's not great code. It's not
Yeah,
for problems that have been never solved before. This thing can't
right.
solve problems that have been never. Is that so? Yeah. What do you think on that?
Yeah, it's not going to think
Yeah.
in an original way about a new problem for
No.
sure. I myself was hesitant to start using any kind of LM for coding because I felt that it's something I need to fully understand myself. But over time, I did start to experiment, especially in the last 4 or 5 months, I'd say. And actually, when I was working on the full stack, right? Because like obviously I have a layer of JavaScript within the HTML on the user interface. It's been 3 years since I've done anything with JavaScript. I'm in a rush. My client
Yeah.
is like,
Yeah.
has
Yeah.
this coming along?
Yeah.
And so to speed up, I'm like, okay, I'm going to ask ChatGPT or, one of these co-pilots, how do I do this in JavaScript? And I found as long as I kept it to these simple kind of queries about like, I ought to know this. It's true. I haven't learned it yet, but can you quickly just describe how you do this basic idea? And then it will give you a good answer. It is maybe middling. There's probably something, if you were a deep coder that had done it for 30 years, you'd be like, oh, come on, that's a computationally inefficient way of doing it, but it still works. You test it immediately. You're like, yeah, that worked. Thank you, ChatGPT, for that quick coaching. But I treat it like coaching. I don't think it's ever
Yeah.
going to sit
Coaching.
down. Like,
Yeah.
there won't be a product manager who sits down with ChatGPT and just says, build me an entire product, unless it's a pretty simple product. Um,
Interesting.
because they're just so complex and there's so many, business requirements that you'd have to do trade-offs against, and coders have to get in the meeting room with the product developer and kick things around. You're not going to get away from that. But I think what you do have, and this is a major trend now because of this, is a compression of what used to be an extremely tall hierarchical stack of coders. So like
Mm,
if you think about the 1990s, and I used to be at Accenture in the late 1990s. And so we would
mm,
have project teams of like 200 people at a big telco. And granted, 50 of those 200 were managers and partners and things
yeah.
like that. But 150 of them were coders. And they were, so these massively detailed business requirements would get written out and handed down the stack. And there's, some guy or gal at the bottom is like, okay, I've got my piece that I'm
Whoa.
supposed to code today. I'm going to code this in C. I'm going to follow the script exactly. And all I know how to do is to code in C. That's like, I'm not thinking about the business. I'm just thinking about the coding, the pseudo code that got handed to me by my consultant lead, right? And that then became the outsourcing model. Oh, we've got
Yeah.
150 people. Maybe
Interesting.
we can just give that to India or Russia or whoever at like 1/10 the rate.
Yeah.
And that continued for a long time. It still exists today. But the idea is still like you hand them specific instructions, just code this.
Yeah.
And what I think the world we're quickly moving into now is where people like me and soon you, who think about things at a business level,
Yeah.
here's
Now get
the
into it.
full flow of the solution. Here's why the solution exists. Here's what we're trying to achieve with it. Here's how we're going to measure success. You can think of all those things because you're a good business person. But now you can also build the damn thing yourself because a lot of it has become no code or low code within a larger platform like Salesforce, for example,
Oh, interesting.
or all sorts of middleware have low code or no code
Yeah.
solutions to that. So all you're doing is building nodes and connections to kind of articulate the logic flow or the workflow of that business. You're
Whoa.
not actually typing out code. And when you do need to do something cutting edge, like what I'm doing with the
Yeah.
client with the LM, you're writing snippets of Python or snippets of JavaScript. And if you don't know how to do that particular function, you just quickly ask ChatGPT. It's solved. It's like having a buddy who just is a somewhat better coder than you,
Yeah.
and you solve it immediately, you test it, you're good to go. Um, and so you're really just using code to stitch together larger codeless things. From your point of view, they're codeless. Of
Yeah.
course, there's huge code within them, but you
Yeah.
don't have to worry about that. You just have to hook them all together. People talk about the API economy, right? You're just hooking
Yeah.
APIs together. You're getting events from one system. You're triggering on the event. You're taking a chunk of it, handing it to something else. And so the business value is in your ability to understand that full solution and just pull it together as parts and pieces and then say, hey, it's done. And hopefully you do it a few times, you can do it quite fast. And the client then doesn't have to worry about, did your coders understand this? Is there something did they not
Yeah.
get it and nobody's going to realize? Because they're just dealing with you and you can just pull the whole thing together. So I think we're moving into this age of the independent solution delivery shop, right? Like the 1 or 2 person shop.
Yeah.
You're not going to do it for like giant enterprises because they're
Yeah.
just too complex. But
Yeah.
for mid-tier companies, yeah, you just pull it together, snap all the pieces, and as long as you understand the business objectives, that thing's going to work.
So this is this is a missing piece that I've had for a long time because it feels like there needs to be a course because I'm doing a lot on free code or no free code camp, one of those
Yeah, I
free
think I
code
know that.
camp or whatever. Yeah.
Yeah,
And it's great. I really love it. I really love what they're doing. But then I'm realizing I'm trying to learn everything, and I cannot
yeah,
learn everything. That's not a good way to do it. I need to pick something I want to do and do that. And so now I've got this giant thing of the
yeah.
podcast thing, but that seems like very big to do because getting 350 episodes into the knowledge base of, but now I've got a little tidbit, which is essentially I could figure out how to do the vector database, but a vector database probably can't even hold that. But the point that I want to make was that the somebody needs to do a course. Somebody needs to do a course on solution development, solution like independent solution development, like free code camp, but like just teaching people how
Yeah.
they can plug things in and like what are all the failure points, like one step up, like because the abstraction, the actual code language themselves, that doesn't seem that important anymore. Although it's, I think I agree with you that it's important to know what you're doing. But ChatGPT can teach you how to know what you're doing as long as you've got the goal. But it feels like the architecture, that whole thing could be a really good course, basically. What do you think?
I do agree with that. I
Yeah.
have seen very, very few of those,
Yeah.
if any,
Yeah.
because I often have architecture questions where it's like, what's the most logically efficient and from an enterprise point of view, kind of well-grounded approach to the solution? And there are almost no, there's like a gap in the market. There are definitely plenty of resources for, if you're a CIO or an enterprise scale architect and you want those general concepts of
Interesting.
doing enterprise architecture in 2024, there are definitely books for that. But there that for guys like us,
Practical.
that's too big.
Yeah, yeah, yeah,
Those concepts are so large that it's almost like, no, I don't really need that. I'm doing a single solution. I'm not doing the entire enterprise.
yeah.
And then you have courses which are more just like coding or how to understand cloud infrastructure. Um, so I think if you learn coding to a basic level, you
Yeah.
definitely are going to need to learn, loops and recursions and arrays and things like that.
Yeah,
But
okay.
you don't have to learn for 3 years, just
Yeah,
learn from, get the basics.
yeah.
Use ChatGPT to start filling things in. You're going to learn as you use it. Obviously, you'll be like, oh, now I remember that. I don't even have to ask, right? It is just like having a coaching buddy. But I found actually one of the best sources or the best kind of learning approaches is there's a company called Manning all online,
Mm,
Manning. They're kind of like O'Reilly, right? You've heard of
mm.
O'Reilly,
Yeah,
the John
okay.
book.
Yeah, yeah.
They're good as well. But what Manning is very good at is they publish live projects. And so it's
Oh,
kind of like a book. You can subscribe to them monthly or you can buy it book by book, but it's like a book that's a project. And what's even more interesting about it is it does not give you
whoa.
the step-by-step instructions to it.
Yeah.
It actually gives you the mission. So it
Oh,
might
great.
break it up into different
Great.
chapters. Like we're going to build a database in AWS that ingests from an on-prem system or something like that. Because you want to learn data engineering. You're going to have to need to know some background before you start the live project
Yeah.
because they're not going to explain all the basics. But once you reach that kind of confidence of like, I've been doing this for a few months, I need to now start holistically understanding how it comes together. A Manning Live project and the topic you care about is really good because they'll just say, okay, chapter one, the aim is to just pull the raw data in and build the first tier of a data lake. Here's what it needs to look like when you're done. Here are generally the 3 steps you need to go through. But I'm not going to tell you much more in more detail about that. Like just figure that out. And it forces you then to like be like, even step one is a bit tough. I got to go research this, right? And the book will say like, here's some really good links that take you directly to how you do this on Azure. And here's the instructions for doing it somewhere else. So it doesn't leave you without resources, but it kind of forces you in a real world context as if your boss or your client had given you this job to go figure it out, right? In this kind of roughly guided way. And once you walk out of one of those live projects, you're like, damn, I really understand how to do it now because I
Yeah.
did it. actually built the whole thing, and I was not spoon-fed step by step.
And there,
This sort of it's this nice happy medium.
and I'm on the website now, and there one appears: build a custom chatbot using LangChain and ChatGPT,
There you go.
41.99, 3 weeks, 2 to 4 hours, beginner.
Yeah.
Very cool. Yeah, I like that. Well, thank you so much for coming on the show. How can people find out more about you and what you're working on?
Probably my LinkedIn profile is the best for that, certainly on the technology side of things. So yeah, do you provide the link?
Yeah, I'll provide it in the show notes, so
Yeah,
on LinkedIn as well. Cool.
great.
Thank you, Ian. Yep.
Thanks, Stuart. This has been a blast.